Hello students, I am Miss Anamika. I will be teaching half part of the physics and I will be mainly doing unit number 1 to unit number 5. Okay. Now I had gone through the homework and I was not very happy regarding the level of your understanding is concerned. So I thought to make a small video on the dimension analysis. Okay. Um, Dimension analysis. Okay, dimension analysis. Let us go through a small briefing about what dimension analysis is all about. Okay, the shooting may not be perfect. Student, please bear with it. Okay, see, dimension in physics. In the note I have given that there are 7 fundamental physical quantities like what? Length, mass, time, current, luminous intensity, quantity of matter. So these are what? The fundamental. Like in order to learn the English, we need to know ABC, isn't it? Similarly, in order to learn physics, you need to know the 7 basic fundamental physical quantity: length, mass, time, current, temperature, amount of substance, and luminous intensity, right? That is given there in your note. So as these are like when I write a word, okay, like word, okay, this word is made up from the English alphabet W, O, R and D, isn't it? Right? So the alphabets have comprises this word. Similarly, in physics, any other physical quantity, when we talk of, that physical quantity should be coming from the fundamental. Okay, take for an example, this is, let me write, this is an area. Okay, let me write, this is an area. Okay, area, when we say, this is basically the length into breadth, isn't it? Any body plane area will be written by length into breadth, right? But this is not the fundamental physical quantity. But as area is not the fundamental physical quantity, but it should be coming from the fundamental, right? Isn't it? So what are the fundamental physical quantity it involve? Then you need to remember, we write mass. Okay, we write mass as m, this way. In dimension analysis, this is a way. Okay, over the between the square bracket we write it. We write length because these are the mainly use. More than this you don't need it. Okay, length. Okay, another is the time we write it by T. Okay, so these are the things. Mass we denote it by M, length we denote it by L, time we denote it by T. Okay, area is length into breadth. So what are the dimensions it involve? Length, this is length means length. Breadth is also what? Measurement of length only, right or not? Right? Breadth is also the measurement of length. So this is also, that means what? Area involves the 2 dimension of the length. Area involves length. Okay, so area involves length how many times? 2 times. Okay, other way also you can also learn this. What is the unit of the area? Unit of area in any unit, it is meter square or centimeter square, depending upon what to say. We even write feet square, isn't it? Anyway we can write it, isn't it? Right? So feet square means length into length. Centimeter square is also length into length. So even from the unit also we can have an idea about the dimension. Okay, so whenever a quantity, if it is not a physical quantity, fundamental, if it is not a fundamental physical quantity, then you need to know the formula, and from there you need to convert it in terms of the fundamental. Okay, like say for an example, you may not understand it. Take for an example volume. Okay, volume. Now you first of all you need to know the formula. Okay, this is volume is what, student? Length into breadth into height, isn't it? This is the general formula for the volume, right? Now what you need to know the formula. Then you say what are the fundamental physical it involve of the 7 laws. It involve what? Length. This also length. This also length. So what is the dimension of the volume? Dimension of the volume is L cube. That means in the measurement of volume, L is involved 3 times. Okay. In other words, what is the unit of it? It is meter cube, isn't it? Feet cube, right? Centimeter cube, right? So centimeter, how many? Length, how many times? 3 times, right? So volume involve the measurement of length 3 times. This information only. So the dimensions, the fundamental involvement, we can know from that analysis, that is the dimensional analysis. Okay, then coming about the another formula. Let me say coming about the another formula, which is widely used. That is, let's say velocity. Okay, velocity. Then, as I have said, you need to know the formula first of all. That's why in the note also I have given you the formula list. Okay, velocity is what? Velocity is displacement per unit time, right? Isn't it? Now let's see. Displacement is also the measurement of length, right or not? Right? And time is also measurement of time. So what is the dimension? The time it goes up. So what it is? L t to power minus 1. So the velocity is L t to power minus 1. Similarly, everywhere you need to know the speed. Okay? Speed is what? Distance by time. Distance is also L, time is L. So this is what? L t to power minus 1, right? In other words, velocity, what is the unit in SI? Meter per second, right? Meter is length, per second is what? Time, inverse. So if you know the unit also, from there also you can find out the dimension. Okay. So I hope this is clear to you. Okay. Then we can find, as I have said, you need to know the formula in order to know the dimension analysis. When you have opened the textbook, so many formulas you will see. Everything you don't need to know. Okay, because you are just in the unit number 1. Okay, what I have given there in the note, you just know those formulas. Okay, with that it will work. If it doesn't work, I will let you know. Okay, now coming about the another simple, we'll do 2-3, like acceleration. Class 9 physics, don't forget it. Okay, formulas at least. Acceleration is the velocity by time, right? Velocity by time. We have already found out the dimension of the velocity. Velocity was what? Displacement per unit time. That is what? Lt to power minus 1, and time is what? T, right? If this t goes up, then it will become what? Lt to power minus 2, right? Acceleration, what was the unit in SI? Per second square. So this is what? Lt to power minus 2, right? So it's very easy. Then in the note I have even shown about the density, right? Or we can draw density. We can know density is mass per unit volume. Then we can even know force. Quite we did it a number of times. Force is what? Mass into acceleration. This is the definition, right? Acceleration is what? Lt to power minus 2, right? Then mass, m Lt to power. So what it is? It is m Lt to power minus 2. Very, very easy, right? Okay, all right. So this is the one you need to know. All right. Now coming about the dimension, one thing, this dimension quantity, this dimension, when we talk of a dimension of any quantity, we are classifying into 4 categories. Okay, one is dimensional variable. I'll just tell you quickly. Dimensional variable, you don't need to by heart it. Okay, you need to understand it. Dimensional variable. Number 2 is non-dimensional variable. Okay, number 3 is dimensional constant. Okay, dimensional constant means a number. Okay, dimensional constant. And another one is non-dimensional constant. Non-dimensional constant. I'm not writing it. Okay, dimensional variable, like just now what we did. Dimensional variable means those who are having the dimension. Okay, like we had seen that area is having dimension, right? What is L square? Volume. Those who have dimension are the dimensional variables. Okay, what to say? Velocity we wrote, force we wrote. So these are what, student? They are the quantities. These are the quantities who have dimension, right? So these are the dimensional variable. Now coming about non-dimensional variable. Okay, non-dimensional variable. In class 10, you have learned something called the refractive index. Do you remember that? Refractive index in the light chapter. Then this is what refractive index is. What? Light speed in air to that of light speed in that medium, right? So it is light speed by light speed. That means what? It is speed by speed, isn't it? Refractive index when we talk of. That means a refractive index is just the measure of speed by speed, right? Yes or no, right? So what? One, does the refractive index have the unit? No. Those who do not have a unit, they do not have dimension. Okay. Area have the unit, meter square, centimeter square. Volume have the unit, meter cube, centimeter cube. Velocity, meter per second. Force, Newton, right? So they have the unit. Those who have the units, they are the dimensional variable. Okay, but refractive index do not have the unit because it is the measure of speed by speed. Okay, that means it do not have dimension. No unit means no dimension. Okay, so a non-dimensional variable means the quantity who do not have dimension. Okay, so the example of it is refractive index. Okay, you are exposed to refractive index, that's why I have discussed about it. Okay, later on in unit number 6 you are going to learn something about the strain. Okay, so that's different. So I'm just going etc. Okay, now constant. There are some numbers. Okay, in physics. Okay, there are some numbers in physics which have the dimension. Okay, like take for an example. Okay,